In a quiet village far from fame and fortune, a young boy tended plants, not knowing his hands were sowing the seeds of a scientific revolution. His name was Gregor Mendel, and his silence echoed louder than any applause the world could offer. Gregor Mendel, the silent revolutionary of genetics, early life and formative years. Born on July 20, 1822, in the rural village of Heinzendorf, located in the Austrian Empire, modern-day Czech Republic, Gregor Johann Mendel entered the world in humble circumstances. His parents were peasants, and life was defined by hard labor on the land. Despite the modest setting, Mendel's childhood was rich in curiosity. He was surrounded by nature, and his early observations of plants and animals seeded his lifelong fascination with the natural world. From a young age, Mendel showed an affinity for learning. His local school teacher and a priest recognized his academic talent and encouraged his education. However, this support couldn't shield him from the harsh realities of poverty. Mendel's family had little money, and he frequently struggled to afford his schooling. In fact, his later university years were interrupted by health problems. Some historians speculate these may have been stress-induced depression. But even in the face of adversity, Mendel persisted. He labored on his family's farm, studied with zeal, and eventually found a path that would allow him to merge faith and science. The monastery, sanctuary for science. At age 21, Mendel joined the Augustinian Abbey of St. Thomas in Brno. Life in the monastery provided not only spiritual solace but also academic freedom. The abbey's library was expansive, its gardens lush and well-maintained, ideal conditions for a budding scientist. Taking the name Gregor, he became a monk, but the title belied the depth of his intellect. While living a quiet religious life, Mendel continued to immerse himself in studies of physics, mathematics, and botany. Eventually, he attended the University of Vienna, where he was exposed to rigorous scientific thought and experimental methodology. Despite being an introverted figure with a gentle demeanor, Mendel's scientific intuition was anything but passive. His thinking was bold, structured, and innovative. The pea plant experiments, quiet genius in action. Back at the Abbey in Brno, Mendel began his most significant scientific work, experiments with pea plants conducted between 1856 and 1863. He chose pea plants carefully. They were easy to grow, had distinctly observable traits, and could be controlled for crossbreeding. Over the course of 8 years, Mendel cultivated and tested over 29,000 pea plants. His observations. Some traits appeared unchanged through generations, while others seemed to skip a generation and then return. He noted patterns of dominant and recessive traits, words he coined to explain what he saw. Mendel discovered that traits were passed down in predictable ratios, now famously known as law of segregation, law of independent assortment. These principles form the foundation of Mendelian genetics. Without even knowing about DNA, Mendel correctly hypothesized the existence of factors, now known as genes, that determine inherited traits. Rejection and rediscovery. Despite the brilliance of his work, Mendel's contemporaries didn't grasp its significance. In 1865, he presented his findings to the Brno Natural Science Society and published them in their journal. But his voice was drowned out by prevailing scientific views that lacked the framework to understand his data. Disheartened but undeterred, Mendel returned to his duties as abbot of the monastery. He spent the remaining years of his life in quiet contemplation and administration, still believing in the importance of his findings. He died in 1884, largely unknown outside of a niche academic circle. But history was not finished with him. In 1900, 3 scientists, Carl Correns, Hugo de Vries, and Erich von Tschermak, independently replicated Mendel's experiments and realized the value of his work. Suddenly, the quiet monk of Brno was recognized posthumously as the father of genetics, and his name was etched permanently into the annals of science. Legacy that lives on. Mendel's impact extends far beyond the field of genetics. His story exemplifies the power of curiosity, patience, and faith in truth, even when the world fails to acknowledge it. His legacy is reflected in modern agriculture. Understanding genetic inheritance helps breed resilient crops. Medicine. From hereditary diseases to genetic therapies, Mendel's laws are foundational. Education. His experiments are taught globally in science curriculums, instilling critical thinking and empirical rigor. Even today, biologists, geneticists, and educators continue to expand on his legacy. An inspirational reflection. Mendel wasn't loud. He wasn't famous in his lifetime. He didn't chase recognition, but he chased patterns, knowledge, and clarity. His story reminds us that greatness isn't always measured by applause. Sometimes, it's found in the quiet persistence of someone who sees what others miss and patiently waits for the world to catch up. Though he passed in quiet obscurity, the echoes of Mendel's work resound through every genetic discovery made today. He didn't chase recognition. He nurtured truth. And in doing so, he became immortal. Not in applause, but in impact.